Hi everyone, thank you for joining us. If you're watching this, hopefully you are already familiar with the general concepts of Interlok: consumers, producers, services, workflows, channel, payload, and metadata. So now we're going to put those elements into practice with a simple Interlok adapter. We're going to set up Interlok to output an empty file to a local directory, and then we're going to use metadata to control the name of that file. So let's get started. Here's our Interlok config screen. As you can see, it's empty, nothing there yet. So the first thing we need to do is give it a channel. And we're going to call this channel S output, file system output. Save that. And as you can see, Interlok has automatically created a consume connection on the left and a produce connection on the right. By default, these are null connections. What's missing, however, is a workflow. So we're going to create a workflow, a standard workflow, and save that. And again, Interlok has automatically created the consumer on the left and the producer on the right. These are all null by default, so any message that happened to come in would simply go out in exactly the same way. There's no services in the workflow or anything to manipulate the message. So we're going to start from the end and work backwards. The null message producer is going to be swapped out. We said we were going to output to the file system. So we're going to create a file system producer, writing the current message to the file system. And where is it going to write it to? Where's the output directory? Well, that's in the destination. So we give the destination a configured destination type, and we tell it to write to a directory called messages out. Now, what if messages out doesn't exist? Well, here is a setting to create directories. By default, this is false because on production environments, for instance, you might not want directories to be created. But for the purposes of this exercise, we do. So we're going to set that to true. Save that. Now across to the consumer. We're not going to consume any specific data here. We don't have any data that we want to put into the system. So how are we going to get things moving? Well, we're going to swap this null message consumer here for a polling trigger. And what a polling trigger does is it continually sends out an adaptress message, an empty adaptress message, in that it has no payload and only a few token pieces of metadata. As you can see, there are different types of polling trigger. Here are some JMS pollers for talking to JMS broker. But we're interested in this one, the polling trigger. And we're going to tell the polling trigger that we want it to operate on a fixed interval poller, which is set by default, and giving it a poll interval of 10 seconds. So every 10 seconds, this is going to output a virtually empty adaptress message. Let's save that. Apply the config. And there we go. So what happens in the messages directory? Well, here it is. It's a subset of the Interlok installation directory because we haven't set messages out to be on any root directory or given it a drive letter. So by default, it will simply end up as part of the Interlok installation directory. And what is in messages out now? Well, we've got 3 empty messages, 0 kilobytes, because there's no payload. What you can see from the file name, and there's a 4th popped up because every 10 seconds a new one will appear. And what we can see from the file name is that the message has been given a unique ID, and that unique ID has been translated to the file name. So let's go and find out how that's happened. Back in the config, we're interested in our file system producer, so let's edit that. And how did it get its file name? Well, let's talk to the file name creator. File name creator here is a formatted file name creator by default, and the file name format allows expressions. In this case, this will output the unique ID of the message as the file name. Adaptress message will be given a unique ID if one is not supplied, and this will this should be unique across systems and times, and it's very much the primary key of message identifiers. But we're going to swap that out because this isn't quite what we're looking for. We wanted to control the name of the file. So let's change the formatted file name creator for a metadata file name creator. And what this will do is if it finds a metadata key, which with key in this case of file name, it will use the value of file name to write the name of the file. If it can't find a metadata key called file name, it will give it this file name, metadata file name creator underscore default. So let's save that, apply the config, and see what happens. All looks good so far. Back in the out directory, we have one metadata file name creator default file. But what you will find is that no more will be created. And that's because Interlok doesn't know of any other file name. So it's continually trying to write the same file name to the same file. The messages with different unique IDs have stopped because we're not telling it to output any files with using the unique ID as the file name anymore. Thing is, if we go back to Interlok and look at the dashboard, we will suddenly find that one of the components has failing messages. This channel is not working. Here are some failed messages. And this is a very useful part of the system. You can click on failed messages and see exactly what's going on. And we're getting a produce exception. Why are we getting a produce exception? Because file system file name exists. The file already exists. The file metadata file name creator default already exists, and we're trying to overwrite it. Except that we can't. Why can we not overwrite it? Well, let's address that. So back into the config. For clarity, I'm going to delete all of these unique messages, just so we're not confused by them later on. Okay, let's drill down through the channel and the workflow. And because we couldn't overwrite it before, we're going to edit the file system producer again. Now we've only got 3 options down the left-hand side. Up here, you can enable advanced options, advanced settings. So we're going to do that now. Personally, I like to have advanced on all the time. But the decision is yours. We're going to look at the FS worker. This is the default file system worker here. But we can swap that for overwrite file. And by default now, this worker will overwrite the file that exists. We're going to apply the config. That's all fine. We look back in the out directory. There's still just the one file there. But best of all, in the dashboard, we have no more failed messages. So we fixed the issue. We are overwriting that file with new files, or we're overwriting that file with the same file name. As you can see, there is only one file there still, although the time has been updated. So that's kind of worked in that we're not getting errors anymore, but it's not quite what we're looking for. So what we need to do is provide a bit of metadata. As you remember, the file system producer down here is looking for a piece of metadata called file name. So let's provide it. We need a service to create some metadata. So let's do just that. Let's add metadata. And we're going to create a metadata key called file name. and we're going to give it value of this is a file name. Let's save that. Apply config. And everything seems to be working. Back in the output directory, this is a file name has appeared. That's good, right? Well, yes. We can now control the name of the file using metadata. What's happening is add metadata service is creating a metadata element called file name, giving it a value, this is a file name. And then on the next step, the file system producer in its file name creator is looking for the metadata key called file name and using the value contained in that key to write the name of the file. And that's good, but we're still not quite there. Because we're still output, this is still very fixed. This is very much a system that won't change. So what we're going to do is we're going to swap this metadata service for something else. We're going to change the type, and we're going to give it add timestamp metadata service. Now what this does is it's going to output a metadata key with the current date and time. And at the moment it's called timestamp, but we need it to be called file name. So we've renamed the metadata key that add timestamp metadata service creates. We also need to look at the date format. And for simplicity, also because on a Windows machine, you can't have colons in the file name, I'm just going to get rid of those colons. So we're still outputting the year, the month, the date, a T, the letter T, the hour, the minutes, and the seconds. And there's a simple way of testing if this is going to work. We have a test button. So let's test what happens when we send it through. There's no input data. We just got to click send. The output, the payload on the output, it was empty on the way in. There were no metadata keys going in, but we've tested this service, sent through an empty message just to test, and the output puts the date and time into a metadata key called file name. There's still no payload. There never was. That's okay. So hopefully, if we click cancel, because we don't need to test this anymore, and save that, and apply the config, back in the output directory, we find that the two file names we created before are still there, and this new file has appeared with the current date and time, and then another one. And in this way, we're creating unique file names based on the current timestamp that infer meaning and that can actually be more useful and more visible and more understandable to someone than the automatically created unique ID. And there you have it. We set up Interlok to output an empty file to a local directory, and we then adjusted the name of that file to suit. And finally, we used metadata to control the name of that file. Thank you for your time.